Hello everyone. So today we will talk about another problem, that is remove nth node from the end of the list. Okay, given a head of the linked list, remove nth node from the end of the list and return its head. Example is 1 2 3 4 5, and the node which we want to delete is the second last, which is this the last, this is second last. 4 we need to remove, and it will be something like this: 1 2 3 5. If it is having only one element, remove that and send it again. If it is having two elements, if you want to remove the last element, which is 2, remove, then the return is 1. Constants are very important. The number of nodes in the list is SC, and SC is rise from 1 to 30. Node value can be from 0 to 100, and n can again rise from 1 to size. Okay, number of nodes. So that is the constraint, and let us try to understand the problem here. The problem is very simple, like we need to remove the last node, right, last n node from the linked list. So one way is that we can find the count. One way is we are going to be just running the counter, and nth node will find the, suppose the length is t, and if we want to remove the last second, we'll be doing t minus n, which will be from the front. For example, last second node total length is 5, so that second node is nothing but total 5 minus 2. Okay, so 5 minus 2, which is 5 minus 2, which is 3, and first, second, third, and the fourth. So t minus n plus 1, the element will be the from the front. So that is the another way. Now we don't want to use extra iterations here. We want to avoid that iterations, and let's see how we can do using the slow and pointer, slow and fast pointer. That is a hint for you. I'll explain how it is going to be working, but now you can use the slow pointer approach and the counterpart and try to solve this question by your own, and then I'll discuss the approach, and then I'll write the code for that. So let us try to understand the approach. Suppose we have 5 nodes, okay, and we want to remove the second last, which is this one node. Okay, so how we'll be doing is, we'll be using two pointer approach. So we'll be having slow pointer, we'll be having fast pointer. Both of them will be pointing to the head. As we have the length which is given, we'll find it, will not find the length. Basically, if we find the length, then it will be taking 2 iterations. Instead, what we'll do, we have 2, right? This is a critical information or important information, you can say. If it is 2 means, suppose we have like this, suppose we are what we'll do, I'll tell you what we'll do, and then we'll see into it. So 2 is the right, so what we'll do, we'll increment our fast pointer by two steps. So first step and second step. So fast pointer will be pointing here. Now both of them are pointing here. The difference between them is of the 2 positions. Okay, now we need to make sure that the fast is at the very end. So here when we increment our fast pointer, we'll be having at position 3. Now what we'll do, we'll slowly iterate this fast pointer towards the end. The condition will be like f should not be equal to null, and f dot next should also be not equal to null. Okay, so f is not equal to null, f next is also not null. We'll increment our pointer by 1. We'll increment here it is pointing, and at the same time we'll increment our slow pointer as well. So slow pointer is here. Okay, I'll just erase it. So increment this size. Okay, so let us try to do that, and now we have slow pointer here, right? Now again fast pointer has been incremented from here to here, as an f is not equals to null, then at the same time it will be here. But now again we'll not be able to move this fast pointer any further, because next is null. So at this position slow is reached here, we need to delete this. Then what we'll do, s tends to next is s tends to next to next, so it will directly point from here to here. So here this is very important node, you can say. Suppose this will be the resultant here, but in case that fast pointer initially when we are going with checking with the length, the fast pointer has reached to the null. So in that case we can understand that the value n is the value which is given for delete is equal to the length of this array. So in that case what we need to remove is, we need to remove the first element. Okay, I hope you got it. We need to remove the first element, and how we'll remove the first element? First element will be simply slow equals to slow dot to next. So it will be pointing here, slow will be pointing, and we'll be removing, will be or we can say head equals to slow dot slows next. Okay, slow dot next, and we'll return the head from here. So that is the another way. Now let us try to write the code for this, and I'll explain you there as well, so you'll understand better. So let us jump into the code part now. Now let us start writing the code for this one. So initially what we need to do, we need to make a counter. So we'll make a counter, we'll name it as counter equals to n, and the first thing which we'll do is we'll check the two cases. So first case is that if our head equals to null, or you can say if our head dot next is null, which means we have only one element. So in that case, so here this will be something like this: head dot next not equals to null. If head dot next equals to null, not equals to null. If head dot next equals to null, which means we have only one element. In that case, we'll just return null from here. Okay. Now one condition is handled here, and the next condition what we know, we'll make a list node, fast pointer which will be pointing to the head again. Okay, and we'll create a slow pointer which will be again pointing to the head only. Okay, so both the pointers will be pointing to the head. Now what we'll do, we'll increment our count, this fast pointer will push the fast pointer ahead by position which is equals to the difference, okay, which is nothing but the n. So n we is having in counter. So I'll explain you again. Okay, so suppose we have counter, if counter minus, or we can say if counter is greater than 0. So in that case, we need to increment our fast pointer by that positions. So fast equals to fast dot next. Okay, and slow we will not do anything, because fast we want to create the difference. So what is the basic goal is that fast pointer, slow pointer is here, fast pointer is here. The difference will decide the slow pointer's position, because if you have more difference, which means the n is greater. So at that same time, the n will be from the end, it will be having that many positions. Okay, so that's the main goal here. So fast equals to fast dot next will do, and fast will be pointing further. And now what we'll do, we'll run our while loop here again, because we have found that one more thing we are forgetting here, to decrement the counter, otherwise it will run infinite number of times. Counter minus. Okay, we'll do that here. Now the difference has been created. Now what we'll do, we'll just run our while loop here, while fast is not equals to null and fast dot next not equals to null. Cases what we'll do, fast is not equals to null and fast dot next is also not equals to null. Fast will increment our fast equals to fast dot next. Okay, and slow equals to slow dot next. Okay, so here the difference is created, and now we are going to be having that case in which our fast pointer is null. Fast pointer is null, which means it can be two things, like it can be only thing that the n is nothing but the length is equal to the length of the this total head or the list node. So here important observation is that when that fast can be null, so fast can only be null when the length of the n value which is given is equals to the nodes, total number of nodes. So in that case only the fast can be null. So we are going to be checking that. So if the fast is equals to null, okay, at this position only the because suppose we have the end difference, right? End difference means slow will be at the very starting, fast will be at the very end, correct? Now whenever we are incrementing a fast pointer in while loop, because fast is fast it will be incremented one position ahead, so fast will be pointing to the null, fast will become null from here only, it will become null, it will not go into this only. So fast will become null in this case, and we'll be checking the condition here that if our fast is equals to null, then what we'll be doing, we'll be pointing head where slow is pointing. Okay, we'll point it to the slows next, and we'll return head from here, return head. Okay, and in other case, which is nothing but the normal one, which is some other values other than the n equals to the number of nodes. So in that case, what we'll do, we'll do slow dot next equals to slow dot next dot next. I hope you are getting this. If you're not getting this, you can just go back where I've explained on the whiteboard how it will be pointing to slow equals to slow dot next, because we'll be at that position, because we'll be at one position prior, and we'll be doing that slows next will be equals to slows next to next. So the other the next value, slows next value, we want to delete it. So that is how it is going to be doing that. Okay, slows next equals to slows next, and we'll return slow from here. Okay, so that is it. Now let us try to run the code and see the output. So it is giving some wrong answer. So it is giving 1 2 3 4 5. It is deleting. Output is 3 5. That should not be the case. Let me just check it. Here we missed this thing. We will not return slow. We'll return head because we want the whole list, not the part from where it is going deleted. So that is it. Let us try to run the code. It is working fine. Let us submit the code here. So it is successfully accepted. So that's it for this video. I hope you got the basic idea of the problem. It was interesting problem for the linked list. So we'll meet in the next video with another such problem. Thank you guys for watching.